Yalla, data modeling. What are we discussing in data modeling? Well, what's the purpose of data modeling? Describe the entities, classes, and data objects relevant to the domain. So data modeling is kind of like taking the data dictionary and placing it in places, creating flows and building relationships around them. And the relationships among them to provide common set or semantic for analysis and implementation. So earlier we kind of like had a conversation around around concept modeling, and right now we're discussing data modeling. Concept modeling is more the story, the structure, and what are things supposed to do and how they work. And data is more like where it goes and from where it comes and all that good stuff. So what's the description? A data model usually takes the form of a diagram that is supported by textual descriptions. It visually represents the elements that are important to the business, for example, people, places, things, and business transactions, the attributes associated with those elements, and the significant relationships among them. Data models are frequently used in elicitation and requirement analysis and design, as well as to support implementation and continuous improvement, right? Because what do we need? Why do we need the data? Well, we need to see like if we're on the right track. We want to see if we're producing properly. We want to see if what we're producing is supporting what we want and all that kind of like cute stuff. So there are several variations of data models. There's a conceptual data model, the logical data model, and the physical data model. The conceptual data model is independent of any solution or technology and can be used to represent how the business perceives its information. It can be used to help establish a consistent vocabulary describing business information and relationships within that information. The logical data model is an abstraction of the conceptual data model that incorporates rules of normalization to follow. Conceptual data model is basically an explanation of the data basically and how it moves, right? It's the concept behind the data. The logical data model is an abstraction of the conceptual data model that incorporates rules of normalization to formally manage the integrity of the data and relationships. It's associated with the design of a solution. Okay? And the physical data model is used by implementation subject matter experts to describe how a database is physically organized. It addresses concerns like performance, concurrency, and security. The conceptual, logical, and physical data models are developed for different purposes and may be significantly different even when depicting the same domain. At the conceptual level, different data modeling notations are likely to produce one second. The conceptual, logical, and physical data models are developed for different purposes. Agree? Or at the very least, I would say yes, and let's move forward from there. It may be significantly different even when depicting the same domain. Okay, Yuki. Why? Because the physical data model is looking at it from a certain perspective. The logical one is looking at it from a different perspective. And the conceptual model is looking from a different perspective. At the conceptual level, different data modeling notations are likely to produce broader, similar results and can be thought of as single technique as presented here. Logical and physical data models include elements specific to the solutions they support and are generally developed by stakeholders with experience in implementing particular technical solutions. Okay? And that is logical and physical data models are more physical, right? The conceptual level gives broader results and can be thought of as a single technique as presented here. Logical and physical data models include elements specific to the solutions they support, right? And they're developed by the low-level stakeholders, which are basically the ones with the expertise in the domain and implementing like particular technical solutions. For instance, logical and physical entity relationship diagrams, ERDs, would be used to implement a relational database, whereas a logical or physical class diagram would be used to support object-oriented software development. Object diagrams can be used to, so object-oriented software development is based on, okay, one second. For instance, logical and physical entity relationship diagrams, ERDs, should be used to implement a relational database. Let me explain that to you guys. So here what they're doing, they're separating something very important because they're telling you that the logical and physical entity relationship diagrams, right? And what are entities are basically like a data point. Like a human being is a data point, like name, full name, email, and then you have kind of like a description of the human being: green eyes, black hair, beard, height, weight, all that kind of stuff. And that's a relationship between them, right? So those are basically a relationship approach when it comes to databases. How databases are built around these relationships. So they're saying the logical and physical basically are kind of like, and physical entity relationship diagrams would be used to implement a relational database, whereas a logical and physical class diagram would be used to support object-oriented software development. So OOP is a lot more, how do I create functions when it comes to the actual business? When it comes to how do I go to the database and find relationships? So I create an object, and from that object I kind of create like I create the things that are necessary. For example, like what's the point of creating a user that's a data point which is a user, an individual? Well, an individual can do what? An individual can sign in, all right? So like I attach a function, I create we call them getters and setters in software development. Because like you get something from the actual database and you set something from the database. So what you're doing is you're kind of creating getters and setters for the users. So like Tariq, for example, has want to visit a place. So like I have to update that place. So but that place is a different class, but it's connected to Tariq. So I have to create that relationship with them. And so ultimately that's basically where object-oriented development starts happening. Like we start kind of like building around objects, which is a user, an entity, a different place. And we create everything that kind of connects to them. And then from there, we kind of like develop the whole system and structure with it. That's what they're talking about right here. So one is the functionality for the actual design and how the database is related. And that's basically like, ERDs are basically, there are languages for databases to be created and to how they connect with each other. And there are languages for how we fill the databases, which is basically back-end languages. Object diagrams can be used to illustrate particular instances of entities from a data model. They can include actual sample values for the attributes, making object diagrams more concrete and more easily understood. Right, that we draw them, this leads to this, and this does this, and in between, these are the functions that happen. There are a lot of ways for us to draw them. And what are the elements? Entity or class. An entity is basically, in a data model, the organization keeps data on entities, or classes or data objects. An entity may represent something physical, such as a warehouse, something organizational, such as a sales area, something abstract, such as a product line or an event, such as an appointment. An entity contains attributes and has relationships to other entities in a model. In a class diagram, entities are referred to as classes. Like an entity in a data model, a class contains attributes and has relationships with other classes. A class also contains operations or functions. Again, a class human, right? Or like, let's look at it this way. An entity is a tree or farm, and it has class tree, and it has class animal, and it has class machinery, right? And it has class farmer. So the entity is the farm, and it holds basically different trees, different class tree versus class bush, right? Because a tree basically, or class plant, and class plant could be type tree or type bush. So that's basically where we kind of like dive into the classes and we create objects out of them. In a class diagram, entities are referred to as classes, like an entity in a data model. A class contains attributes and has relationships with other classes. A class also contains operations or functions that describe what can be done in the class, as generating an invoice or opening a bank account. Each instance of an entity or class will have a unique identifier that sets it apart from other instances. 2, attribute. An attribute defines a particular piece of information associated with an entity. Exactly, right? Like what are the attributes of a tree? Because you're looking at a tree as a class, or where you're looking at a tree, and I go like, okay, the attributes of a tree are basically branches, leaves, trunk, and شو اسمه, and roots, and space, or root space, or root height, or length, or whatever it is. And including how much information can be captured with it. It's allowable values and the type of information it represents. Right? Like, because you go like, tree, basically, what a branch, what's allowed, like when I say branch, okay, is it yes or no? Is it like, no? There's the color of the branch, there's the size, there's a separate kind of like how many times it flips. Look at it this way, the difference between a palm tree and a fucking olive tree, right? Palm tree kind of grows a certain way and has like, its branches are also leaves, whilst the fucking olive tree is kind of like a bit more complex. Attributes can be described in a data dictionary. Allowable values may be specified through business rules. Right now we're connecting everything that we were like reading before. Attributes can include such values as name, values, meanings, description. We read those in the data dictionary. Description, height, length, lifespan, right? If we're talking about an olive tree and we're looking at a farm, because like, we can, other class could be animal, and animal from a chicken that's not a mammal, a bird, to a fucking like crocodile that's a fucking like reptile, to a fucking a hog that's a mammal, and all that kind of beautiful stuff. The relationships between entities provide structure for the data model, specifically indicating which entities relate to which others and how. Specifications for a relationship typically indicate the number of minimum and maximum occurrences allowed on each side of that relationship. For example, every customer is related to exactly one sales area, while the sales area may be related to 0, 1, or many customers. So those relationships are table relationships. Like, again, going back to the reference of like one farm has multiple trees, but one tree cannot have multiple farms. It can only exist in one place. I'm not saying one farm can have multiple chickens, but every chicken has one farm, right? Although if we have a class of eggs, then one chicken can have multiple eggs in multiple seasons and multiple times, right? So that's how we kind of like structure things. And it's a relationship database. So like, why is this related to this? Well, Tariq is related to that place because he went there 3 times already, right? Or Tariq is related to that place because he liked it on social media, and that's basically how Instagram gets your information, or information from you, or data from you. The term cardinality is used to refer to the minimum and maximum number of occurrences to which an entity may be related. Typical cardinality values are 0, 1, and many. It's one-to-one relationship. Like Tariq could have one body, it can't have more than one body. But Tariq could have more than one car, for example, so it's one-to-many relationship. Or Tariq is not related at all to anything. That's a bit harsh. But yeah, there are things that are not related to each other, but might actually meet, like, a farmer is not directly related to the tree, the farmer is related to the farm, and the farm kind of is related to the tree, right? So it's just... the relationship, there's always a way to connect to something, but like, not all of them are connected directly. In a class model, the term association is used instead of relationship, and multiplicity is used instead of cardinality. So here, each occurrence of this entity is related to minimum maximum of this other entity. Yeah, I guess 0 to 1 to many. And diagrams. Both diagram models and class models have one or more diagrams that show entities, attributes, and relationships. And the diagram in a data model is called an entity relationship diagram, ERD. In a class model, the diagram is called class diagram. See, entity 1, entity 2, this is basically an ERD. Each entity is shown as a rectangle with an entity name. The cardinality is, this is any number 0 to many, 0 to 1, only 1, any other number from 1 to many, right? You see this here, the definition. Like, it could be a relationship with 1, this is 1 to many, or this is 0 to many. Like, I could have a relationship or I could not have a relationship. And here, class diagrams is practically the same, but the difference is it kind of like has also the functionalities. Like, what are the operations that are attributed to this class? Like, a chicken lays eggs, an olive tree grows olive seeds, right? A palm tree grows date seeds, and everyone has different operations, and they have like, they're connected to different classes, different attributes, or whatever, shit, like something. There's kind of like a thing that's going around, and that's what we're trying to like connect with. And I don't know, did I explain any of this properly? Uh, when it comes to a class, the relationship is determined based on the the diagram itself, as in like, you know, there's a one-to-one, one-to-many, zero-to-one, or zero-to-many. And there's also many-to-many, by the way. And many-to-many are kind of like, you know, many-to-many relationships are, Tariq could have many farms, and each farm could have many owners, right? So like, you know, I could have 3, 4 farms, and I could be also a part owner on other farms. So like everything when it comes to ownership, farms could have many owners, multiple owners, and owners might have multiple farms. So it's a many-to-many relationship between the owner and a farm, a user and a farm, through ownership. Whilst when it comes to class, it's basically like شو اسمه. Well, it's the same relationships, right? But the only difference is they're indicated. They're indicated differently. Like the only difference is just the fact that when it comes to classes, the functionality of the class itself operates within its own parameter. How to explain that? You explain that by simply. Interesting. Yeah, so like, you know, a chicken lays eggs. And so the attribute of chicken is laying eggs. But to lay an egg, a chicken has to sit for like an hour before it lays it, or has to wait 27 hours before it lays every 27 hours it lays an egg. Those are the operations. Laying egg is the operation. There's a relationship between the chicken and the egg, yes. But because an egg cannot exist without a chicken, but like in a relationship diagram, there are eggs, but there are chicken eggs, ostrich eggs, duck eggs, right? But in a class relationship, there's just a chicken and its egg. And any relationship to different classes are more attribute-based relationships. Because every class has its own operations, and these operations connect with other classes. Like every coop could have like one-to-many chickens, right? But the chicken on its own is a class, and a coop is a class. And a coop basically could have chicken, could have of different animals, it could be a barn, whatever, right? Like I'm really trying to think in classes and what they have inside of it. And what operations happen within the class are normally stored in the class, and that's basically what they're showing here. I love you guys. I hope I did a good job at this. Metadata, a data model operationally contains metadata describing what the entities represent, when and why they were created or changed, how they should be used, how often they are used, when and by whom. There should be restrictions on their creation of use, as well as security, privacy, and audit constraints on specific entries or whole groups of entities. So like, you know, when it comes to metadata, that's basically the data about the data. That's the hidden, I don't know, when I am actually developing something, or when I'm kind of like, the metadata around a human being would be different than the data the human being has. It's the description of the actual شو اسمه. It optionally contains metadata describing what the entities represent, right? Because the entity of user, for example, is basically has a name, Tariq, and all that shit. What it represents is basically what's stored in the metadata, and why they were created or changed, how they should be used, how often they are used, when and by whom. These could be restrictions on their creation or use, as well as security, privacy, and audit constraints on specific entities and whole groups of entities. So they kind of like declare the rules and structures of every entity that we're using. Which, yeah, why the fuck not, man? In code, normally the metadata is kind of like designed around the types and the relationships, and basically like, you know, I can actually show you. Like, So here's the table on the left. Can you see it? I'm not sure. All right, let me just, I'm gonna view the file, man. All right, is this better? All right, yeah. So here, basically, like on the left, is basically the actual table where where that holds basically Simon, first name, last name, NIN, I have no idea what that number is, and the department ID. Well, the metadata is the design of the table, which is basically like an employee ID, which doesn't show right now because it's on the side. But the first name is a varchar. A varchar is basically how many characters? So it's 50 characters. It's a data type. So these are the rules of the table and what goes into the table and how it goes. And see, there's employment start date. Employment start date is a data type of date. So like I cannot put a name there. I have to put a date. And that's basically the metadata of the table. And that table itself, which holds like Simon, Thomas, and Simon, Thomas, and all these fucking people. Here is basically the data of the table, and this is the metadata of the table, which is basically description, primary key of the table, employee first name, employee last name. That describes what data the table is actually taking. So that is what metadata is. Are we cool? Do you guys like me? I don't know. All right, amazeballs. And usage considerations. What are the strengths? Could be used to define and communicate consistent vocabulary used by domain subject matters experts and implementation subject matter experts. Fuck yeah. Review of a logical data model helps to ensure the logical design of persistent data correctly represents the business need, provides a consistent approach to analyzing and documenting data and its relationships, of course, offers a flexibility of different levels of detail, which provides enough information because you're designing data models and structuring them and come and go and put here. And you're also designing the flow among them, right? Like because we have classes and we have Shu'ismo. Informal modeling of information held by the businesses may expose new requirements as inconsistencies are identified. Following data modeling standards too rigorously may lead to models that are unfamiliar to people without a background in IT, of course, because like I'm talking to you right now, and as I'm trying to explain the different data points, I'm connecting them differently. So. I don't know. I remember when I started studying software engineering, it took me a while to figure it out, but now I'm doing much better, I guess. May extend across multiple functional areas of the organization and so beyond the business knowledge base of the individual stakeholders. Sometimes you just don't need to have a clue about the data model, like who the fuck cares? So like how you're organizing your data is not necessarily something that everyone should know, because some people just want the end result of everything data oriented. La 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 la. Anyways, that's where we are, and now our next stage is decision analysis. Fuck yeah. We love you guys. Bye.